This video is to cover Chapter 3, Elixirs of Death, from the book Silent Spring by Dr. Rachel Carson. I'm going to cover what Dr. Carson herself talked about in the chapter, but I'm also going to cover a few other things. When she first starts the chapter, she talks about how pesticides are in everything, but she starts by talking about what I would call natural pesticides. At least they're not synthetic. These were commercial pesticides that have been used for hundreds of years that include the heavy metals, quote unquote, that are cadmium, zinc, and the one she focuses on quite a bit is arsenic. Now, arsenic is a naturally occurring element, and it's found in rocks where it co-occurs with other minerals. And for years, centuries, it's been a bane to humans. Humans suffer quite horrendously from this poisoning all around the world. This picture here is lesions on someone's feet due to arsenic poisoning of groundwater. So while it's a problem for people, it's actually been used in agriculture because arsenic sprinkled on plants will not harm the plant, but it does prevent things like spider mites and other insects that can damage crops from bothering them. So arsenic is still being used today in different parts of the world. It's sprayed. It has its own health problems that people are currently dealing with. Other naturally occurring pesticides were the pyrethrins or the pyrethroids, which come from chrysanthemums. They are chrysanthemums are a sort of common plant you see this time of year, little orange flower. They are naturally have a chemical in the flower that's resistant to bugs that would eat them. So when you spray a chemical synthesized from that, or just even sprinkle the flowers themselves, it stops things from eating the nearby plants. Chrysanthemums and pyrethrins and pyrethroids, which come from them, are so common that if you have a dog, you've probably given your dog flea and tick repellent that contains pyrethroids. It's fairly common. Additionally, tobacco has a handful of compounds inside it that prevent most insects from eating it, though if you know a little bit from history, the tobacco worm has been a real problem in this country. But one of the issues that I wish Dr. Carson had explained in greater detail in the book, though she does mention it, is that over time all in pesticides have the same problem, is that things begin to become resistant to them. So there was always a market for developing new and better insecticides, pesticides, herbicides, whatever you want to call them. And the ones that really concern us in this chapter are the ones that came to market in the late 1930s. So in the U.S., it wasn't until right around World War II that they became an issue. And the one that Dr. Carson talks about the most is DDT. DDT stands for diphenyl trichloroethane. The name is so long it wouldn't even fit on one line on my slide. It was synthesized in 1874, but it was sort of a time when people were just making chemicals to see if they could make them. It wasn't really used for pesticide until 1948, and I wrote ish here because it depends on what country you're talking about. But World War II brought people to places in the world where malaria is prevalent, and there's in the scientific literature. There's some evidence that people who live in these parts of the world have somewhat natural, quote unquote, degrees of immunity, while people from European descent have less of that. So there were a lot of issues with DDT, and the issue was brought to the forefront during World War II. I included what's called a stick diagram here, this figure 1, which is the dichloroethane. We're going to be talking about hydrocarbons. I just want to show you the part that is the hydrocarbon. I'm going to try to draw here, is right here. Where this little dot is a carbon, and this carbon would, before it was converted into DDT, was just surrounded by 4 hydrocarbons. Let's erase those. So real quick, I know chemistry was a while ago for you guys. Hydrocarbons just are compounds that contain hydrogen, hydro, and carbon. And they're frequently used as what's called organic. The word organic, right here, organic, is a word that has a very different meaning in your grocery store than it does in the chemistry department. Organic just means that it has carbon and hydrogen. Sometimes it has more, it has other things in it, but they're compounds that are naturally made through life. This one right here, methane, is carbon in the middle, surrounded by all these hydrogens. You probably know already that methane is a naturally occurring compound. Bacteria make it. We all know that cows make it. Even you make it. But methane's a naturally occurring compound. In the late 1800s, chemists were really interested in turning methane into other things. So what they were able to do is to take methane and to pop off one of the hydrogens. So here we have 4 hydrogens. And here, one of the hydrogens have been replaced by a single chlorine atom. That makes chloromethane. Chloromethane in and of itself is an issue. We won't get into that, but it's a compound that has issues as well. If you take off and do 3, you get chloroform, which is like a plot point in a lot of movies. And then finally, if you pop them all off, you get tetrachloride, where you've replaced every hydrogen with a chlorine. So just be aware that these things are done in a lab through chemical reactions, and that is how they ended up synthesizing DDT, was they took off all of these little pieces right here, and they added other things on besides just chlorine. The diphenols and the diethanols all came off, and they made bigger and bigger synthetic structures. And a lot of these compounds, because of the chlorine backbone of them, are taken in ways that other non-organic compounds are not. So this is an actual sign. This was not like, somebody made this as a meme. This was an advertisement for DuPont. I couldn't find the exact year, but it was about 1930. DuPont was the big chemical company in the United States, still is. This is frequently like misstated to better living through chemistry. But the actual thing was, hold on one sec. Had to get rid of the pop-up. This was an actual advertisement from the 1930s, and it sort of speaks to the mindset of the time, which in the 1930s into the 1940s and beyond, really up until Dr. Carson's book, there was sort of a belief that science could fix everything. It could fix, the scourge of, disease-carrying pests. So this was, I want you to keep this in mind when you think about DDT and other things. It wasn't that people just were like willy-nilly, let's kill people. They really believed at the time that chemicals could make your life better. This is actually a picture. I like this picture. It's from the CDC. I know it says Phil, but it's from the Philadelphia CDC. And DDT as a compound was initially used on people before it was even used as a spray. So it was initially made as a dust, and that's what they're doing to this soldier in this image, is that the dust is in this, right here. They're dusting him for various, I'm assuming, insects, or potentially even to stop him from getting malaria. But also lice and other sort of personal pests were an issue during World War II. So they would literally dust soldiers with DDT. The problem, the solution with DDT, is that DDT was very cheap to manufacture once they got the hang of it. And it comes in different forms. There's pathways of toxicity for different chemicals. And DDT, as a dust, is not particularly toxic. It doesn't absorb very well on the skin. Even as a dust, as it's being applied here, if you breathe it in, it's not terribly toxic. It's when it's dissolved in oil. So the problem becomes DDT, because it's that organic compound, dissolves very nicely in oil. And not only that, it gets taken up easier in oil. So they found that different pathways of exposure to DDT caused a lot of the problems. Additionally, because the dissolving in oil was eventually used to spray, large-scale spraying for malaria in various parts of the world, including right here in New Jersey, they would spray mostly at night, because then they would give time for the clouds of DDT spray to settle. But it would bioaccumulate, which I'm sure you've heard before, and I'll talk about in the next slide. And when we went to see the osprey, we talked about how it thins bird shells. Additionally, because, birds, not osprey per se, but other birds eat insects, when the DDT killed the insects, and also secondarily it kills crabs and whatnot, there was less items available for wildlife to eat. Additionally, the birds themselves became toxic to other things. There's a couple case studies you guys talked about where DDT was an issue with regards to cats. DDT is known to be what's called an endocrine disruptor. You may have possibly heard of this before, but an endocrine disruptor is one that causes the hormones in your body to not work properly. This is, again, an issue with the fact that it's a hydrocarbon, and because it's made out of carbon, your body lets it into different pathways that it wouldn't normally. And the CDC calls DDT a possible human carcinogen, while the World Health Organization calls it a probable human carcinogen. Those terms have slightly different meanings in science that you don't really need to know. It has to do with likelihoods. But the DDT problem is not just that it's bad for people or that it's bad for wildlife. The DDT problem is also an issue because malaria is a real problem. And DDT, at least for a while, made it look like we were going to win. And I'll come back to that in a minute. Just to review, this was not in the chapter, but bioaccumulation and biomagnification, I sometimes hear students use them interchangeably, and that's not the case. Bioaccumulation, so if you guys vaguely remember, I wish this picture was drawn more as a pyramid, as a trophic pyramid. You have a small amount of whatever let me change the color of this. You have a small amount of whatever this toxin is. Do you see these crosses? And as they're found within a trophic level, so this would be one trophic level, this would be another. Notice as you move up the trophic level, there's more and more and more of these. The increase as you move up a trophic level occurs because the compound is more soluble in fat, and the fat is frequently metabolized from one organism to another. What this picture leaves out is that, for every pound of this mouse, the mouse is going to eat 10 pounds of this. And for every pound of snake, I guess, it eats 10 pounds of mouse, and so on and so forth, till you get to, when we're at the top level, if this was drawn as a pyramid as it should be, because this is a fourth level consumer, for every pound of bird, it's eaten 1,000 pounds of the energy that was originally in the primary producer, the grassland in this case. What that means is that bird is now containing not just the toxins from the snake, but that the snake absorbed from all the mice it eats, and then from the mice it eats from all the plant it eats. So keep that in mind. Biomagnification is between trophic levels, and bioaccumulation occurs within a trophic level. There are some compounds that don't biomagnify, typically ones that are not found in fat tissues, but the ones that tend to be fat soluble tend to bioaccumulate. Dr. Carson goes on to talk about other hydrocarbon pesticides, though, as I'm sure you've read, it's mostly about DDT. Heptachlor is an interesting one to me because Heptachlor is actually older than DDT. It's been banned as well, but it was an interesting case because Heptachlor actually breaks down pretty quickly. But one of the problems with Heptachlor is that what it breaks down to is a compound called heptachlor epoxide, which is much more toxic in the way that it's taken up than Heptachlor, and it actually causes hepatitis. The name, I know, sounds like it's because of that. It's not. Hepta has to do with the number of carbons in it. But the daughter chemicals in this case were much more toxic than the original. And this is something that we've seen more often as we talk about more and more pesticides and pesticide research. Then I'm going to kind of combine these all into one. Right after DDT, there was another synthetic that was beginning to be used. Eldrin, dieldrin, aldrin, whatever you want to call them, were all more toxic than DDT. Specifically this one. This Eldrin one was really toxic, really, really toxic. The dieldrin was 5 times more toxic on the skin, but when it was dissolved in liquid, it was 100 times, and that went up exponentially with the Eldrin. There were instances, Dr. Carson talks about case studies where Eldrin was actually responsible for just using it according to the label. Actually was tied to a case where a family pet died, and then so did an infant. Chloridane is another one that she talks about briefly in the chapter. It's really of interest to me only because it's such a long residence time. Chloridane was also banned at the same time DDT and the Eldrins were. But the residence time for that one is years. Years and years it stays in the original form. One of the ones I think that's really of interest that didn't get a lot of talk about in the chapter, but she did talk about a little bit, is organophosphates. This is probably of interest to me because it's still being used today. You can't buy organophosphates well, you can't buy organophosphates to be used as a pesticide anymore. So you can't go to the store and buy them and spray them around your house. They're too toxic for regular citizens to use. But it's still used in agriculture. What's kind of scary about organophosphates is they were actually originally developed as a chemical family due to their ability to be used as nerve agents, which is kind of disturbing. And the CDC found that many forms of produce still have measurable amounts of organophosphates on them. It's sort of ironic that the organophosphates were found on a lot of fruits and vegetables in the 90s and sort of spurred the organic food movement, even though organo is right in the name. Organophosphates are used for pesticides and herbicides, but they're considered I don't want to say less effective, but some people who complain about the banning of DDT, one of the criticisms they have of organophosphates is they actually don't persist in the environment very long. They break down relatively quickly. Luckily, their daughter chemicals are not quite as toxic as some of the DDT relatives, but they're still not, anything you want to play with. So what the problems is even though organophosphates break down quickly, that spurs more people to use them. And since we know that most people get exposed during application, that causes more people to be exposed than would be exposed with DDT. It's a valid concern with regards to trying to get rid of pests. And organophosphates are actually responsible for a large number of poisonings, even going on today. Just in 2014, there was a series of I think it was blueberry farm workers, migrant farm workers, who were badly poisoned. Oh, I'm sorry, it wasn't blueberries, it was oranges. That was it. I forgot for a second. So the organophosphates are like a concern, especially because they're still being used. She ends up the chapter with talking about herbicides. She gives reasons like they were used to make the roadway safer. Like if you let the sides of the road grow with tall weeds, you're more likely to, have a car accident. And one of the big things where herbicides were an issue, they were used, especially in the 50s, to treat weeds in lakes. Even then, there were a handful of invasive species coming into the country, and they would spray the weeds on there. Unfortunately, the ones that they were using, many of which were arsenic, by the way, arsenic-based, ended up making the groundwater unusable. And in the 50s, it was a real issue. Some of the famous ones are penta or the dinitros, which penta is still on the market, dinitro is not. But these are dangerous. And dinitro in particular, which is, again, an arsenic-related one, has resulted in death by accidental poisoning often. In the 1950s, it was used in England to treat... So after you take potatoes away, you have to kill the vine. So in order to use the field again next year. So what was happening in England and Ireland is they would normally use sulfuric acid to do this, but that was expensive. So they used dinitros and arsenics to do that. Unfortunately, when they would spray the fields, warnings went out to the general public, but they destroyed a lot of this washed off into wells, and a lot of it also ended up eaten by cows who would occasionally wander away from their fields. They would eat these, dead and dying potato vines, and they would be poisoned. There was actually a farmer's wife in England who died because their well was poisoned and nobody realized. And I had to throw on here when we talk about herbicides, Roundup. It is, in all likelihood, many of you have Roundup in your garage right now. Roundup is still sold. It's sold by the Monsanto company, which we will talk about in other parts of this class. And just this past August, there was a man who used Roundup about 20 to 30 times a year as part of his job. He was actually in charge of the landscaping for a high school. And he got soaked by Roundup twice, like where it spilled all over him. And it has been tied to his cancer. He has non-Hodgkin's lymphoma. And due to a statement by the World Health Organization and various doctors, it was shown that they used the words again. It was probable cause for his cancer, and he was given the largest award for a single person to get for being poisoned by one of these pesticides. Silent Spring is an important book. We've talked about it in class a bunch of times. Why? DDT was banned officially globally, though banned is a strong word and globally is not really accurate. It's still used on an emergency case-by-case basis, especially when there are malaria outbreaks. There is no mistaking that when it was initially used, malaria dropped drastically. There's no arguing on that. It absolutely did. But one of the problems with DDT is some people forget that it was already showing signs of pesticide resistance in the U.S. Before it was banned. And even though that was not the case throughout parts of Asia, eventually it would have been. So there's something to be said for the case of only using it as an emergency case-by-case basis, which is still being done. I showed you guys 2 articles from Dr. Carson, one at the time and one more recent. People still call her Dr. Death to this day, which is kind of crazy to me. They blame her for malaria deaths because they feel that her book resulted in a pesticide being removed from the market that would have saved lives. And while I don't agree with their argument on a personal level, they're not completely wrong in the sense that getting rid of DDT as a possible malaria control likely resulted in more malaria. It's sort of hard to argue that against that. That being said, I don't think I would blame her to the degree that they do, but that's just on me. And again, pesticide resistance, the more you use a pesticide, the more likely your target population is to become resistant to it. That's sort of happening right now with a lot of our organophosphates that are still being used. A lot of the pests that they target are being developing a resistance to it, which is a problem for your generation. Here's my work cited. I'll leave that up for a second in case you want to actually look at it. And that will do it for this video.